So we have here a computer simulation that will shows how the image form in a concave mirror. So there are three rays needed in order to create a reflection of image in front of the mirror. So we will use a ray diagramming with the use of computer simulation. So here is the object that we will use. We are using candle as our object. This one is the candle. So I will place the candle. The object location will be at the 2F. I will place that at the 2F or the center of curvature. Okay. Now this is the first ray. The ray is coming from the tip of the object. So this is the incident ray, light coming from the candle, and it hits the surface of the mirror. So once it hits the surface of the mirror, it will be reflected towards the focal point. So this will be ray 1. Ray 2, light coming from the flame of the candle, will hit first the focal point and then hits the surface of the concave mirror, and then it will be reflected parallel to the principal axis. So as you can see, they are parallel to each other. Now the third ray, again, light wave is coming from the flame of the candle. It hits the center of the mirror or the vertex, and then it will be reflected again after it hits the surface of the mirror. So as you can see, the three rays intersect. So there will be meeting of the three rays. So the meeting of the three rays will be the location of the image. So we have here the image formed. So let us describe the image. So we are just dealing with qualitative characteristics of the image formed by a concave mirror. So let us first have the image size. What can you say about the image size? As we can see, this is the original object, the size of the original object, and this is the image. So they are same size. Now in terms of orientation, so the image here is inverted, and the type of image, since the image is formed in front of the mirror, so this is a real image. Okay. Now what if we will place the object between 2F and F, or between center of curvature and the focal point? Is there a changes in the qualitative characteristic that will be created or formed by a image formed by a concave mirror? So again, we will need three rays. This is the first ray, and then this will be the second ray that light waves will hit the focal point first before it will be reflected parallel to the principal axis. The ray 1 is coming from the tip of the flame, so it's moving straight or parallel to the principal axis. This is the incident wave. And then once it hits the surface of the mirror, it will be reflected to the focal point. And the third ray will hit the center of the mirror or the vertex and then reflected. So the intersection of the three rays will be the location of the image. So the location of the image here is beyond 2F. So it's beyond 2F. Now, in terms of image size, if we will compare that to the object size, which is bigger? So as we can see, based from the simulation, the image size is bigger than the object size. Now, in terms of orientation, so the image is inverted, and since the image is formed in front of the mirror, so this is a real image. What if I will place the candle at the focal point? So is there an intersection of the three rays? So here in front, you can see that there are no intersection in the three rays. So this, okay, so, this will be the ray 1. This will be the ray 2 is going here, not hitting the surface of the mirror. Ray 3, although it hits the surface of the mirror, but it did not intersect with the with the first ray. So if we extend a broken line behind the mirror, there are no intersections. So here, if we place the object at the focal point, we can see that there is no image that will be created. Okay? Now, what if this time we will place the object closer to the surface of the mirror or the vertex or inside the focal point? So, what do we observe right now? So, here, this is the ray 1. Okay? The incident wave is hitting the surface of the mirror and then it will be reflected towards the focal point. Ray 2, it hits the mirror but it will reflected this way parallel to the principal axis. But if we extend this line, you will see that there's a meeting between ray 1 and ray 2. Now for ray 3, it hits the center of the mirror and then reflected again. If we extend the broken line behind the mirror, the three rays meet. So that's why the image formed is behind the mirror. So that's the location of the image. In terms of size of the image, it is bigger than the object. And this time we have a virtual image. Why do we have a virtual image? Because the image is reflected behind the mirror. This time we will describe the qualitative characteristic, the image formed by lenses. So through computer simulation, first we are dealing with converging lens or a double convex lens. So still the object that we will use is a candle. So this is our candle. So we have here two surfaces in lens. So we have the first surface on the left side and we have the second surface on the other side. So that's why you can see we have two focal point. First focal point in the first surface, second focal point in the second surface, and twice the focal point in the first surface and twice the focal point in the second surface. So let us place the object here beyond 2F. Now, how are image formed in lenses? So we are dealing again with ray diagrams. So we will use three rays. But since it is a lens, we are dealing with transparent object. There will be no reflection of light. Instead, refraction of light waves will happen. So ray 1, again, the light is coming from the flame of the candle. And then this will be your incident light waves and it hits the lens axis. And then it will pass through or bend. So there will be refraction of light. It will be refracted to the focal point in the second surface. Ray 2, this will be your incident light wave. But first it will hit the focal point of the lens in the first surface before it hits the lens axis and then refracted parallel to the principal axis. Ray 3, this is the light that is coming from the flame will hits the midpoint or center of the lens and then it will pass through or refracted. So as you can see, the three rays intersect or meet. The meeting of the three rays, that will be the location of the image. So if the object location is beyond 2F, the image location will be between focal point and 2F or twice the focal point in the second surface or on in the right side of the lens. Now in terms of size of the image, as we can see right now, the size of the image formed is smaller than the size of the object and the orientation of the image is inverted. And what type of image formed here? Since the image is formed after the lens or on the right side of the lens or in the second surface, so the image is a real image. Now, what if we will move the candle at 2F? So as we can see, again, there will be meeting of the three rays. The intersection of the three rays will be the location of the image. The location of the image is at 2F. Now, in terms of image size created, they are just the same or equal in size, same size, but the orientation is inverted. So the image is inverted and the type of image is still real image because the image is formed in right side of the lens or in the second surface of the lens. Now what if the object is located between 2F and F? So we observe that again the three rays intersect or meet. So this will be the location of the image. It's beyond 2F in the right side of the lens or the second surface of the lens. The size of the image is larger than the object size. So in large image. And the orientation is inverted and the type of image is real image because it formed in the right side of the lens or in the second surface. This time, let's move the object location at the focal point. What do we observe? So if we will trace the ray, this will be ray 1. Ray 2 did not hit the lens. Ray 3, although it hits the lens axis, but there are no intersection or meeting of the three rays. So here we can say that if the object is at the focal point, there will be no image that will be created. Now what if this time let's move the object closer to the lens or between focal point and the vertex of the lens. So we observe that there are meetings of the three rays. So we have here the ray 1, ray 2, and ray 3. If we extend the broken line here, they intersect in the first surface or on the left side of the lens. So that's why the image is located in the left side of the lens or in the first surface of the lens. So it's between F and the vertex of the lens in the first surface or in the left side of the lens. And the size of the image is bigger or larger than the original size of the object. And the orientation is upright. And the type of image is virtual. This time virtual because the image is formed in the left side of the lens or in the first surface of the lens. Now this time, let's deal with diverging lens or concave lens. So again, here is our object. Let's move the object here beyond 2F. So you can see the three rays intersect in the first surface of the lens or in the left side of the diverging lens. So there are no intersection here in the right side. So the intersection or meeting of the three rays are located in the left side of the diverging lens. So that's why the image form is here where the three rays meet. So the location of the image is between focal point and the vertex of the lens. And we have here the size of the image is smaller than the original size, but it is upright and virtual. Now what if we place that to 2F? Still the same. So we still have smaller size of the object, location still the same between F and the vertex of the lens in the first surface, upright position of the image, and it is still virtual. Now if the object location is between 2F and F, the size of the image is still the same, smaller in size, smaller than the object, upright, and virtual. If it is at the focal point, still the same. There is an image formed in divergent lens, smaller than the object, upright, and virtual. Same with between F and the vertex. So the object's image is still smaller than the object, upright, and virtual.